In this video, I'm going to go over how to add fractions that have a common denominator. Before doing that, consider this problem. If you've got 2 cats plus 1 cat, I'm going to get what? How many cats will I have? I'll have 3 cats. Now, if I said I have 2 cats plus 1 dog, well, I can't really do much with this. I can't say I have 3 cat dogs, etc. So notice when we're adding things together, if it's not just a plain old number like 2 plus 1, we sort of have to be talking about the same thing. Like we could add cats and more cats together, or apples and apples together, oranges and oranges together, etc. Well, it's the same way with fractions. Let's say somebody says, what's 2 sevenths plus 1 seventh? It's like they're saying 2 sevenths plus 1 more seventh. And that's just like adding 2 cats and 1 cat. We would end up with 3 sevenths. Now, you could draw a picture of this. For instance, you want to try to break something up into 7 pieces. It's kind of hard. But, pretend 1, 2, 3, 4, 5, 6, 7. And let's see, I'm broken that up into sevenths, and I also break this up. So imagine you have a pie that, is broken up into 7 pieces each. And you're going to take 2 pieces from this pie, so that's 2 sevenths of that pie and 1 seventh of that pie, and you can see you're going to end up with 3 sevenths. Each slice of the pie is a seventh. So basically with fractions, it only makes sense to add fractions if the denominators are the same, and we're just going to keep the denominator the same and add the numerator. Add the numerators. Notice I don't add the denominators. The denominator stays the same. It's like I have 2 of these guys, which are sevenths, plus 1 more of these guys, which are sevenths. So I've got 3 of these guys, which are sevenths. So instead of writing sevenths in words, it really also makes sense to say I've got 2 sevenths plus 1 more of these sevenths, and my answer is I've got 3 of these sevenths. Okay? Sort of like 2 cats and 1 cat equals 3 cats. All right, so let's do some problems where we've got fractions that have a common denominator. See how we do. Let's take 4 ninths plus 1 ninth. Okay, so we check out we're talking about the same thing. They're ninths, so I simply write the denominator down and add the numerators. All right, so we can do that in our head. 4 plus 1 is 5. All right, not so bad. Now, the same thing is true if you've got 3 fractions, 4 fractions added together. They all have to have the same common denominator. The denominator has to be the same. So let's say I was adding 3 elevenths plus 2 elevenths plus 1 11th. Okay, they're all 11ths, so you write the denominator down, and then you add the numerators. So 3 plus 2 plus 1 is 6. I've got 6 elevenths. All right. Now, let's spice it up a bit. Let's take 2 ninths plus 4 ninths. Whoops. All right. Again, I've got a common denominator, so it's going to be ninths. And 2 plus 4 is 6. Now, this is not simplified. When you're adding fractions, you want to write your answer in simplified form, which means reduced to simplest form. So there's no common factor in the numerator and denominator. So you need to reduce 6 ninths. Now, there are different ways you could do this. One is just by the prime factorization method, where you prime factor both the numerator and denominator so you can cancel out the common factors. Or you could do it by dividing the top and bottom by 3 in your head. But in any case, your answer is 2/3. All right, so here are the 3 answers for our first 3 problems, adding with common denominators. Okay, so let's go on to another one. How about 5/8 plus 1/8? Okay, put it on pause and try it on your own. So what do we get here? We have a common denominator, so it's still 8s. 5 and 1 is 6. Then we could reduce. All right, I'm going to reduce this one differently. I see there's a common factor of 2, so we could divide the top and bottom by 2. Now you don't need to show this, but I'm going to, just so you see how I'm getting my answer, which is 3/4. How we doing? Isn't this fun? All right, number 5. Shaking it up a little bit more, we've got 5/12 plus 7/12. Okay, put it on pause and try this on your own. Remember, we're going to simplify it. First of all, we have to make sure the denominators are the same, and then we just write the denominator. We never add denominators. So 5 and 7 add up to 12. Okay, we do not have a proper fraction anymore because the numerator is not smaller. So there's two ways we can go here. We could just divide, or we could reduce. And in each case, it actually, for this problem, you get the same answer. 12 divided by 12 is just 1. Okay. All right, let's do another one. 6/7 plus 5/7. Try it on your own first. All right, what do we have here? Denominator is 7s, so we can keep 7 in the denominator. And now we've got 6 plus 5, that's 11. Now, we have an improper fraction, but it is reduced because there are no common factors. This is a perfectly fine answer, leaving it as 11/7, or you could change it to a mixed number by doing 11 divided by 7. 7 goes into 11 once, and the remainder is 4, which goes in the numerator, and 7. Both of these are correct. It depends if you want to write your answer as an improper fraction or a mixed number. If you are given directions to write it one way or the other, then do that. Otherwise, both of them are at least simplified as long as there's no common factors in the numerator and denominator. So here's another one like the previous problem. Go ahead and try that on your own. All right, they're both 9ths, so we have a common denominator, so we write the denominator. 7 plus 6 is 13, and it's reduced because there's no common factors. So we could leave our answer that way, or we could change it to a mixed number by doing 13 divided by 9 is 1, remainder 4, and the denominator is the same. Remember, when you write it as a mixed number or an improper fraction, the denominators are always going to be the same. Okay, let's try a different problem. 7/10 plus 9/10. Try this on your own. You want to write your answer as a reduced fraction. All right, denominator is the same, so we could just write the 10 down. 7 and 9, 16. All right, now at this point you see there's a common factor, so you could divide the top and bottom by 2. 16 divided by 2 is 8, and 10 divided by 2 is 5. So it's an improper fraction, which is fine, or you could change that to a mixed number by doing 8 divided by 5. Now, alternatively, when you have 7/10 plus 9/10 and you got 16/10, if you notice it's an improper fraction, if you want, you could divide first before reducing. So let's see what would happen if I had done that. So I'm doing 16 divided by 10, that's 1, and I've got 6 left over, 6/10. And now I just reduced the 6/10 because it's not reduced yet. So I could divide the top and bottom by 2, right? The 1 is still the whole number part, but 6 divided by 2 is 3, and 10 divided by 2 is 5. And you would get the same answer if you would have changed it to an improper fraction first, right? So either way, and remember, 8/5 is a perfectly fine answer unless you were told not to leave your answers as improper fractions. All right, try this one. 9/14 plus 11/14. Put it on pause. Try it on your own first. Again, we have a common denominator, 14. 9 plus 11 is 20. Now it's up to you if you want to reduce first or change it to an improper fraction first. I'm going to reduce first because they're small enough numbers to do that. I'm going to divide the top and bottom by 2. 10/7, and now it's reduced, so that's okay. You could leave your answer like this, or 1 3/7. See, fractions aren't so bad. Okay, last problem. Try this. 9/10 plus 9/10 plus 7/10. All of them have the same denominator, so it's tenths. And now we add the numerators, which is 25. Now we need to reduce that, or you can change it to an improper fraction, to a mixed number first. I'm going to reduce it. 5 goes into both numbers, so 25 divided by 5 and 10 divided by 5 is 5/2. Perfectly fine, or 2 1/2 as a mixed number.